everyone, myself Satya, Department of Mathematics, SNS College of Technology. So in previous classes we started one problem. I think we are going to solve one by one. So in today's class also we are going to continue the same problem. Okay. So in the previous class we just solved this problem. Okay. We got the eigenvalues and we started the eigenvector and we got lambda as 1. For lambda as 1 we are getting x1 as 1 0 0 and for lambda equal to 2 the eigenvector is 0 1 1 up to we completed in the last class. Okay. Today we are going to have the topic, the same topic. When lambda equal to 3 then what is the eigenvector, that is the thing we are going to see now. Okay. So we can have the same terms. Okay, just lambda value as 3. Okay, 1 minus 3 is minus 2 0 0 then 0. Yes, 3 minus 3 is 0 then minus 1 0 minus 1. 3 minus 3 is again 0. Okay. Then into x1, x2, x3 which should be equal to 0 0 0. Okay. Now you can check the first two rows whether it is same or different. If it is different, go for cross multiplication method. Okay. Here it is different one. That means we are going to start with 0 0. Okay. The next thing is 0 minus 1. Then minus 2 0 again 0 0. Okay. So we can put the values x1, x2, x3. Okay, x1 by, we take the cross multiplication which is 0 minus 0, then x2 by, again 0 minus 0 is 0, then minus 2 into minus 1 is plus 2, okay, then equal to x3 by 0 minus 0. Finally, we are going to get x1 as 0 and x2 as minus 2, then x3 as 0, you can divide here by minus 2, finally we are going to get x3 as 0 minus, 1 0. This is third eigenvector. So now we completed step 1. Step 2 is we are going to verify whether the eigenvectors are orthogonal or not. Okay. That means we will have the conditions. So we need to check whether we are going to satisfy that conditions or not. Okay. So eigenvectors are x1 as 1 0 0, x2 as 0 1 1, x3 as 0 1 0. Okay. The next step number 2 is we need to check whether the eigenvectors are orthogonal. Okay. For orthogonality, we have the condition. The conditions are x1 transpose x2. Okay, that means x1 transpose means we need to change the column as row. So 1 0 0 and x2 as 0 1 1. If you are multiplying normal multiplication. Okay, so 1 into 0 is 0, then 0 into 1 0, and 0 into 1 is 0. Finally, we are getting the answer as 0. Okay, the next thing is x2 transpose x3. And x3 transpose x1. Okay. Okay. If you verify in the same way, we are going to get the value as 0. So from this we can say the eigenvectors are orthogonal. Okay. So the next thing is step number 3 is we need to find the normalized eigenvector. Okay. So normalized eigenvector will have a formula. Okay, for x1 we are going to take the first x1 is what? 1 0 0. Okay, for this we are going to find one L. Okay, L is nothing but square root of, we are going to find this element square. So 1 square and the next element is 0 square and next element is 0 square. So we are going to find the root of. Okay, that is how to divide here. So if you are dividing this 1 by 1, 0 by 1, then 0 by 1. Okay, finally we are going to get the answer as 1 0 0. Okay, for here there is no change. Okay, in x1. We go for x2. x2 is 0 1 1. Now tell me what is the value? Yes, 0 square and 1 square, again 1 square. You can square all the elements, find the sum, and then finally take the root. So which is nothing but root 2. So here on we divide root 2 and here also root 2 and here also root 2. Okay. This is called normalized eigenvector. Now tell me what is x3? Yes, 0 1 0. Okay, you can find the squares, after that find the sum, take the root in the final step. So which is nothing but the same one we are going to get. Okay, now the next thing is step number 4. Step number 4 is we are going to write normalized model matrix, which is nothing but n. Just collect the terms as a column. Okay, so first thing is 1 0 0 and the next thing is yes, 0 by anything is 0 and 1 by root 2, 1 by root 2 and the third thing is 0, 1, 0. Okay, this is called normalized model matrix. Okay,
The next thing is step number 5 is we need to verify whether this n is orthogonal or not. For that we will have the condition n transpose equal to n transpose n equal to I. That means after finding matrix multiplication, finally we are going to get the identity matrix. That is this condition. So from this we can say n is orthogonal. Okay. Step number 6 is step number 6 is what? We need to find the diagonal matrix. We will have the formula. So D equal to n transpose an. Okay. N transpose is what? To change the row as column. Okay, finally we are going to get one matrix. Then A is the given matrix. N is again the same matrix. Okay, we are to multiply one by one. Finally we are going to get one matrix. That is, we already know the concept in the diagonal. The eigenvalues which is going to place it. Okay, so the eigenvalues are 1, 2, 4. The remaining elements are 0. Okay, actually I want to verify this matrix whether I am getting this matrix. Okay, so this is called the diagonal matrix of the given matrix. Okay, thank you.